So that means basically we are suppose given this tree 1 2 3 4 5 6, right? We have to give let's say 7 8. Then what we have to return is basically, if we see from this side, okay, if the eye is here, then what all we can see, we can basically see 1 3 5 6 and 8. With this all guys we have to return. So the basic idea is to find the BFS, right? So if we do the BFS, we will get 1, then we will get 2 3, then we will get 4 5, then we will get 7 6, and then we will get 8. So we know we get everything in array, and then we can return the last guy of the array. Okay, so let's try to solve with this approach, and we'll try to optimize it on the way. So basically what we need for BFS, we need a queue. Okay, to save the BFS, let's say we are having a BFS array here. Okay, then we have to push the root inside queue. Okay, and next, while queue dot length is greater than 0, what we will do is first let's take the length, const length equal to queue dot length. Okay, and for let I equal to 0, I less than length, and I plus plus. We also need to maintain the level, so let's say const level. Okay, then we'll say const node equal to queue dot shift. Okay, and then if there is a node left, go and add it. Okay, and if there is a node right, then we can again go and add the right node. Okay, and then we have this level, and inside this we can push node dot val. Okay, and after this loop is done, we can say BFS dot push level. Okay, and we also need to return our results, right? So now we have the level, then we know, right, that our result will have the last guy from that particular level. Okay, let's run it. Okay, somewhere it has thrown an error that cannot find length, so we have used length here, while q dot length 0, q dot push root. Okay, let's have this also. If there is no root, then return an empty array. Okay, there's same issue we are facing. Let's check out. We have a queue, we have a res, and we have a BFS array, and then we have pushed the root inside queue. Okay, while q dot length equal to 0, length equal to q length, we have level. For I0 len I plus plus, we did a node shift. Okay, if there is a node left, we have added node left. If there is a node right, we have added node right. Okay, and then level order we have pushed. Okay, node dot val. Ideally there should be no issue. BFS level node left tuck tuck. Okay, shift node left, node right, while q dot length, q dot push root. GTH. Okay, we have to check. Okay, so basically not much of an issue. We are not returning, I guess. Let's see. Okay, that error was not making any sense, right? But it's fine. Return the rest. Now if you see, we only need the level, right? There is no need for the BFS. Okay, so we can remove the BFS. That is the first thing we can do here. Okay, because we only needed the level, and for each level we needed the last guy. Now if we only need the last guy, so that is if I is equal to len minus 1, correct? That is the last guy. So if we can say if I equal to len minus 1, this is the guy we want to put, right? So we can simply say rest dot push and node dot val. Okay, in that case we will not be needing this level also. No need to push, this is not required. Okay, let's run again. Okay, submit. Okay, similarly for the right side view, we know that for I equal to 0 case always we have to add the node val. Okay, that's it.